Okay guys, let's have a little look at the bookwork then for the geometric progressions. This is question or intro on long-click. Here's the formulas. So if you just want to use the formulas for now, you can use the sum of the first n terms of a geometric progression. A times r to the n minus 1 in a bracket, all divided by r minus 1. Or you can use the alternative form, Sn is equal to a 1 minus r to the n in a bracket, divided by 1 minus r. Yeah, and the infinite sum, S infinity, provided that we have this condition here, the modulus r is less than 1, then we can write down this formula, S infinity. The sum of the sequence, the infinite series, is a over 1 minus r. Okay then, but if you want to hang on, we'll do the derivation now. It shouldn't take too long. Given a GP then, here it is written in generalized form, isn't it? AR squared, all the way up to AR to the n minus 1. I've written the term preceding that, the AR to the n minus 2 term. Okay, there. So there's Sn, this should be a plus, of course. And then what we're going to do is multiply through by r. So let's multiply this equation here through by r. So r of these will equal, and times all the way through by r. So here you get r times a, which you can write as AR. Then r times this will be AR squared, won't it? And AR squared will give you, times r will give you AR cubed. And how far do we get to? This term here will give you AR to the n minus 1 when you times that by an r, because you just add 1 to the index here. And the last term here, when you times by r, it will be AR to the n. So there we are. There's equation 2. Now what we're going to do is do 2 take 1. So let's do that. Take that on the left, because it's equal. So we got equals RSN minus Sn, which I've written here, is equal to, and then we want to take these away. Now if you look at it closely, you'll see that when I take this, take that, they will cancel. This, take that, they will cancel. So you've got like a diagonal line there, a diagonal line there. So this diagonal line continues, doesn't it? And you can see it illustrated. So maybe I should put that in. I'll put it in grey, so that it's not going to too badly affect what's written. So take that will cancel, and you can just carry on doing that all the way down to here. Yeah, so that must have cancelled with the one that went before. Can you see that? So that was what we were doing, was this line, this section here, take away this section, and all those in between terms cancelled each other out. So we're left with this, AR to the n, which is here, take away, and the only thing that's left here is a. That's what we have. So now just rearrange things. See, the Sn is common on the left, bring that outside a bracket. We've got r minus 1 not of, because there's a 1 here, isn't there? Implicitly. So let's write it explicitly. And so we got r minus 1 times Sn on the left equals, bring out the a as common through a bracket, and we've got r to the n minus 1. Then we'll just move this down from times down to divide, provided it's not 0. And I'll mention about that in a moment. And here's our formula. Sn that we mentioned at the outset is equal to a brackets r to the n minus 1 over r minus 1. Now if we times top and bottom by minus 1, so a minus over a minus, it'll be the same number, won't it? So a minus over a minus, if I run that through the bracket underneath, it will change that to a plus, but the first term will become a minus. So we got that. If I run the minus through this bracket, this one will become a plus, and this term will become a minus. So this is the equivalent form, or the alternate form, if you wish to use it. If it's easier sometimes to use this, you may prefer to use that one. Okay, so either of these is the sum of the first n terms of a geometric progression. Now, a couple of little things, loose ends to tie up. First of all, if the modulus of r is smaller than 1. Well, if r is smaller than 1, as n gets increasingly large, tends to infinity, and r is less than 1 in terms of its modulus, if you put that into a calculator, to high values of n, this will get increasingly small. So these powers, these r to the n's, will tend to 0 as n tends to infinity. And as such, that will tend to 0. So let's look at the second one, because that's easier to use. That will tend to 0. You'll just be left with 1, won't you? So the top value is a over 1 minus r. So this is in fact the sum to infinity of a GP, provided that we have this condition holding. Okay, one tiny little thing to say. We said that we can't divide by this unless as long as r doesn't equal 1. Well, it doesn't make sense. This is not a GP if r was 1, in a sense, because basically it's times 1 squared, which is still 1. So you've got the same term repeated all the way through. And that's easy to work out anyway. So it's we don't lose any information by just assuming that r doesn't equal 1, because that's the trivial case anyway. Okay, then that's the intro done for geometric progressions. Bit of bookwork done there and the formulae. So all the best, as I say, on this section. Hope you get on okay. Any feedback? Give us a buzz, send us an email, let us know how you're getting on, and I'll catch you in another section. Cheers.